Hello everyone, myself PIYUSH and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Nusari. And the name of subject is Power System Planning and Design, which comes in 4th year, 8th semester. Right now we are discussing the chapter number 1, that is Transmission Line Design, and this is the module number 1.5. So in this section we are going to discuss about the insulators. So what is insulator? Insulator are used to insulate a live conductors from the pole structure and earth. Okay, what are the major role of insulator? Insulator are used to insulate the live conductor from the pole structure and the earth. So insulator are manufactured for different voltage levels. Okay, at a different voltage level we can design different types of insulators. There are like pin type insulator, suspension type insulator, strain type insulator, shackle type insulators are used. Okay, here we shall study all these insulator and their properties. So let's first study all these properties. So first property, that is high mechanical strength. So insulator should have high mechanical strength as it has to carry the weight of conductor and withstand the force due to the wind and storm or ice. Okay, so it should have high mechanical strength. Second, good dielectric strength. So high voltage conductor is placed on the insulators. It is pin or hook is at ground potential, so the material experience high dielectric stress. Okay, what is the meaning of this sentence? That high voltage conductor are placed on the insulator, so one point of the insulator is connected to the high voltage conductor and its pin or hook at a ground potential, so the other point at a ground potential, so the material is going to experience a high dielectric stress, right? So the dielectric strength of the insulating material should be good enough so it can withstand this stress. So flashover may not be occurred in this situation. That's why we require a good dielectric strength for our insulators. If it is less than, the insulator gets punctured, so whenever the dielectric strength is going to be decreased, at that time the insulator is going to be punctured. Okay, third one, this is the second one, and third one, high resistance to earth. Conductor is at high potential, there are possibilities of leakage from surface of insulator to ground. Basically the resistivity of the material should be high and there should be no leakage current. To increase the resistance of the leakage part, its shape is made special types. Okay, then after fourth one, that is high safety factors or high factor of safety. The ratio of puncture voltage to flash over voltage, the ratio of puncture voltage to flash over voltage is called the factor of safety. This factor should be as high as possible. Next, noise, non porosity, that is the material used for the insulator should not be porous, otherwise moisture or water that is going to be absorbed by the insulating material and its dielectric strength is going to be reduced. So our material should not need to absorb the moisture or water from the surrounding medium, right? So this is the fifth one. Now sixth one, that is the ability to withstand the change in temperature. As the insulator is subjected to change in temperature, the material should be such that can withstand the change in temperature. So we need to choose the material which is not a positive temperature coefficient or negative temperature coefficient, but the resistivity of the material need not to be changed very rapidly by changing the rapid temperature of that material. So it should be withstand of change in temperature. Now we are going to talk about the material that we are going to use in insulators. Okay, so basically we are going to use three type of material. That is first one, that is porcelain, second one, that is glass, and statite. So porcelain, first one, porcelain is used for making the insulator for the overhead lines. When the mixture of kaolin, quartz and feldspar is taken in certain portion and is heated to high temperature, the resulting material is porcelain. So we need to remember that the combination of all these materials. Dielectric strength of the porcelain is 65 kV per centimeter. Its compressive strength is more than its tensile strength. The ultimate compressive strength is 6 to 000 kg per centimeter square, while the ultimate tensile strength is 400 kg per centimeter square. So as we can see over here, the compressive strength is higher as compared to its uh, tensile strength. Okay. Now porcelain can be glanced. Porcelain possesses all the property mentioned above, so it is widely used as an insulating material. Now second one, that is glass. So glass can also used for the making of insulator, but its use is limited as it is difficult to cast. Okay, the glass is very difficult to cast when the shape is irregular. So molded tongs glass is used. Okay. So a predefined or molded glass is going to be used whenever we are going to use it as in insulating material. So it is difficult. Its dielectric strength is very high, that is 140 kV per meter centimeter, and cracks are developed due to the change in temperature. That is the disadvantage of the glasses. So cracks etc. can be easily detected as it is transparent, and glass is cheaper than porcelain. Moisture easily condense over its surface because it is in property. So dust, moisture etc. is going to be easily condensed on the glasses, is accumulated over it, which cause the leakage of the current, and ultimately the dielectric strength of that insulating material, or we can say dielectric strength of that insulator which is made of glass, is going to be decreased. Satite, third one, that is satite. So it is magnesium silicate. Magnesium silicate, its tensile strength is high compared to that of the porcelain, so it is used in making strain insulators. So remember that. Next, we are going to talk about the types of insulator. So there are several types like pin type insulator, suspension type insulator, strain type insulator, and shackle type insulator. We are going to discuss all these four types in detail. So first, starting with the pin type insulator. As we can see, here is the demonstration of pin type insulator. So in pin type insulator, threads are cut at lower portion of the spherical shape of the porcelain. Okay, and threaded bolt is inserted in the into it, and the bolt is fitted in the steel arm of it. So here we are going to pass our conductor from this thread and bolted it over here, and in this figure we can see over here. Now a groove is provided on the top of the insulator, as we earlier see in the figure, in which the conductor is going to be placed and is tied with the help of soft binding wire when there is slightly bending on the lines. Okay, or ultimately we can directly put it on the groove that is provided for the conductor. Over here, as you can see, here is the groove where we can easily place our conductor, or if it is little bit of bending at the time, we can cover it, or we can say we can bind it with the other binding material or binding wire. So when there is a slight bending of the line of the insulator are made such that there are sufficient porcelain between the conductor and the pins. Okay, so the sufficient dielectric strength is available. The shape of insulator is made corrugated so that the length of the leakage part increases, which prevent the leakage of the current from the conductor to earth. This proposal is called as a rain shaded. Due to the rain shaded or rain shade, the inner portion remain dry even when the rain there is rain. Okay, so that is where the shape of the insulator is looking like this. So whenever rain is going to be or we can say whenever in the monsoon season, the under part, or we can say the lower part, is always going to be in wet conditions. Okay, or we can say it is not going to affect due to that rain condition. So the dielectric strength is also improved at that time also. So single piece pin insulator is used for less voltage. Okay, you need to remember this, the single piece of insulator is used for the less voltage, that is from the 11 kV to 25 kV only. 11 kV to 25 kV only. And for the higher voltage, two piece insulator used for 33 kV, or three piece insulator is used for 66 kV are used. So for higher voltage, bulk porcelain required is more, and its shape of the insulator is made in two or three pieces, and these are cemented together for increasing the dielectric strength of that insulator. Then it is placed in the furnace, and construction of single piece pin insulator is shown in the figure. Let's see the figure first. And 3 pin insulator is also shown in figure 1.7. So this is the 1.6 figure and this is 1.7. So here as we can see, this is 1, 2 and 3 pins type insulator, and this is single pins type insulator. So here we have top groove, this is the neck, this is the rain shade from where the water is going to fall down, and this lower portion is not going to be affected. So again, this is the cement or top piece. Over here we can see the groove, then after this middle piece and bottom piece. So there are 3 total number of pieces. Okay, now we are going to talk about the second insulator, that is suspension type insulator. So in pin type insulator we used to up to 33 kV. It can be designed for 66 kV, but it become bulky. Okay, so for that become ineffective as an insulator become useless when it is get punctured. Okay, so or mechanically damaged. So while in suspension type insulator there are different discs, are depending upon the system voltage. Okay, the requirement number of discs are used and the whole string is not required to be replaced. So over here as you can see, this is the string of disc type insulator. So if any one insulator is going to be punctured, at that time we can only change that disc from that suspension type insulator. We do not need to change the whole insulator. Okay, so if the middle or the last one insulator is going to be get punctured or damaged, at that time we can only change that last one insulator pin or disc. We do not require to change the whole suspension type insulator. In figure 1.8, 2 discs of cemented cap type suspension type insulator are shown. Okay, to increase the length of the leakage part, groove are provided as shown in figure. Due to this, the inner side of the disc remain dry even under the rain condition, that we already know. A steel pin is cemented at the bottom portion of the disc. On the top of galvanized cast iron cap is cemented. Okay, the groove is provided in it, which is pin of unit above is fitted with the locking pin, so that the pin cannot be come out easily. So we need to remember that pin do not need to come out easily, because we are going to place it in the groove of the suspension type insulator. So the string is placed using the required number of the disc. A hook is provided on the top of the it, with the help of which string is hanged from the cross arm. A clamp is provided on the bottom of the disc to carry the conductor. So let's see the figure first. This is the figure. This is the disc number 1. This is the disc number 2. Over here we have the pin, so which is going to connect the conductor. We are going to connect our conductor over here, and we are going to connect our tower arm over here. And this is the metal cap, and this is the cement, with the help of which we can connect this both the caps. Okay, so cement capped type suspension type insulator. Next we are going to see the string type insulator. When there is a straight run of the line, the string is intermediate pole remains in vertical plane, as the tension of the conductor on the opposite direction are equal, and there is tension due to the weight of the conductor only. But when the lines take a sharp turn, or in the beginning of the line or the ending of the line, the tension are not balanced, so more tension is developed on the strings. So the string is required which can withstand such high tensile force. Okay, remember that whenever we are going to connect our string with the ending of the line, beginning of the line, or sharp turning, at that time tensile is uneven and tensile force is increasing at that point. For this specialty, design strain type insulator are used. Generally, construction of strain type insulator is same as that of general purpose suspension type insulator, but these are designed at a greater tensile strength. A sketch of strain type insulator is shown in figure. Let's see the figure. Okay, here is the strain type insulator. It is absolutely similar to that of the suspension type insulator, but the tensile strength of the strain type insulator is much higher than that of suspension type insulator. To increase the strength, 2 strings are joined in parallel. Okay, 2 strings, that is, this is the one string and other string is connected with the parallel of it. So we can divide the tension between 2 strings, and axis of the strain type insulator in the horizontal direction, while that is the suspension type insulator, it is in vertical direction. So remember these terms also, for that is the difference between vertical and horizontal for the suspension type and strain type insulators. Now last one, that is shackle type insulator. So shackle or a reel type insulator are used in the beginning or the ending of the low voltage distribution at the beginning of ending of the low voltage distribution line, or when line takes sharp turns. It is reel shaped with the hole in the center through which the bolt is passed. Okay, it is fitted with U clamp, and the U clamp is fitted on the cross arms. So conductor is kept on the groove provided on the center portion and tied with the help of soft binding wires. Okay, so this is the soft binding wire, and from here we can cycle type insulator, we can here connect our conductor. This is the cross arm, and from here we can bolt or fitted our conductor. So this is the cycle type insulator, which is going to use at low voltage or ending and starting of the transmission line. Now we are discussing about the comparison between pin type and suspension type insulator. It is very important with respect to your examination also, so please pay attention over here. So comparison between the pin type and suspension type insulator is shown in the table. So let's see the table. First, this is the base, pin type and suspension type. So what is the base? First one, that is application voltage. So pin type insulator up to 33 kV, while suspension type is more than 33 kV. Economy: when insulator fails the whole system, whole insulator has to be discarded, or we need to change the whole insulator. While in the suspension type we can change the particular disc, and we do not require to change the whole insulator. It is the advantage. Flexibility: when the line voltage is increased in future, the old insulator are to be replaced by the new one, because we need to replace, because the dielectric property or dielectric strength of the insulator is going to be fixed. While in the suspension type we can increase the number of disc, and by adding the disc we can also increase the dielectric strength of the overall insulator. So flexibility is very good. So this is also advantage of suspension type insulator. Now, protection against the, as the insulator is on the earth hit lightning arm, so there is a protection against lightning. That is the advantages. Okay, the conductor is below the cross arm, there is no cross protection against the lightning. So that is the disadvantage in suspension type insulator. Now, mechanical: pin insulator is rigidly fixed protection on the cross arms, so it is difficult to withstand against the excessive wind pressure. While in suspension type, this is the string swing. In this, the string swing in the direction of the wind. Okay, so the string is saved, so it is not opposing the waves. Okay, height of the pole: so insulator is on the cross arms. Okay, so for center ground clearance, the height of the pole has not be capped more. That is the advantages. And insulator string is below the cross arm. So in suspension type, this is the cross arm, and we need to provide our insulator below the cross arm. And in the pin type insulator, we need to provide this is the cross arm, and we are providing on the above the cross arms. So the overall height is going to be increased. So this is the advantage of pin type insulator, and this is the disadvantage, because we are putting our cross arm downward directions. Now we are going to see the voltage distribution of suspension type insulator. Okay, so in suspension type insulator, this is the cross arm, and this is number of 3 discs, that is A, B and D. These are 3 discs, and over here we are going to connect our conductor. This is the overall voltage, that is the E, that is the total voltage between the conductor and the cross arm, and the voltage, that is E1, E2 and E3, that is with respect to the discs. Now, for overhead line transmission, electric power on 33 kV and above, suspension insulator are used, that we already know. The string consists of number of porcelain disc insulator connected in series to one another by metal link. Okay, by metal link. So all the discs are connected by metal link. Now, the line conductor is secured to the bottom disc of string, and the top disc is flexibly attached the cross arm of the pole or tower, that we already seen in figure. Now the suspension insulator string is stressed in tension only, bearing the weight of the conductors. Okay, that we already seen in the figure. The number of discs in series in the insulator string depending on the line voltage, because if we are going to increase the line voltage, at that time we need to increase the number of discs. The higher the line voltage, the larger the number of discs. Now As shown in fact, table shows the number of discs that required for the different voltage in suspension types. Let's see the table first. So for 11 we required one disc, for 33 we required two discs, for 66 we required five discs, and so on. For 400 kV we required 22 discs. So this is the table for number of insulator discs used for transmission line for different voltage level. You need to note this down for future uses. Okay. Now moving forward, we are going to study the string efficiency. So string efficiency is related to the insulators only. So in previous section we already seen that the distribution of voltage across each unit of the insulator string is not uniform. Why not uniform? Because the conductor to ground clearance for all the different disc is different. Okay, for 11 kV a single unit of 255 mm to 145 mm insulator is sufficient. If does not mean that 6 unit will be sufficient for 66. So it does not mean 6 unit is sufficient, because the voltage distribution between each string is different, right? As in the calculation is was found that 5 units provide sufficient insulation for 66 kV only. So let's study this in detail. Thus, the effort to make the use of minimum required number of insulator unit is insulator string to ensure continuity of supply and also save the cost of the insulator from the damage. When the voltage across the unit nearest to the line increase, the flashover or breakdown will occur. This in turn will cause a breakdown of all the units. Okay, so if one first disk is going to be a breakdown, next that is the second disk, so it is also going to be breakdown, and so on. The last disk is also going to be breakdown. Such a situation should be avoided. At the same time, engineering economics demand that minimum possible number of units are going to be used. So we do not need to be large number of unit for safety purpose. We cannot use large number of unit because it is going to be cost more. So for economical aspects, we require minimum number of disks that is possible without flashing over or without breaking over voltage limit. So this lead to the definite string efficiency. So this is going to define a string efficiency. So string efficiency is equal to E divided by N into E1. So what is E? That is total voltage across the insulator string, and N is in units. Okay, and that is the total number of disc or total number of units, and E1, that is the highest voltage across the nearest unit to the conductor. So whichever the disc is nearest to the conductor, at that disc the voltage level is going to be highest. So we need to consider E1 as a highest voltage level, that is the at a first disc, the voltage level at a first disc, and E, that is the total voltage across the insulator, and N, that is the number of disc or number of unit that we are going to use. So this is the equation of string efficiency. Now as a percentage, efficiency is equal to E divided by N into E1 into 100. So we are multiplying it with 100 if we are finding the string efficiency in percentage. In term of the flashover voltage, it is defined as N is equal to flashover, that is the efficiency is equal to flashover voltage of string of N units divided by N into flashover voltage of the one unit, that is at the topmost unit. Thus string efficiency decrease with increase in the number of disc insulator unit. So if we are going to increase the value of N at that time, if we are going to increase the value of N at that time, the string efficiency is going to be decreased. Now we are going to see some of the specification of transmission line, that are first specification that are phases, that are single phase or three phase. Second, that is the frequency, that is in hertz. Power to be transmitted, that need to be in kilowatt. Then after distance of transmission line, that need to be in kilometers. So power factor at the receiving end side, we need to consider the power factor at the receiving end side. Then after voltage at in kilowatt. Then after possible voltage drop across full load. Then after losses in transmission of power, limitation of corona loss per kilometer. These all the factors that we need to specify for economical operation of our transmission line. Then after, its efficiency should be good, change in temperature according to the weather condition, clearance over voltage ground, wind pressure and ice loading on the transmission cable, and also line to be designed for heavy loading, that is medium loading, and or light loading condition for mechanical design point of view. At the end of the following data, we obtain the construction of the transmission line, that are from all this data we are going to obtain the conductor and size of the spacing. Then after, types of the tower span to be used. Then after, number of insulator per string. Then after, size of the ground wire. on the tower and its location, then after tension on the string straining the conductor, and then after the sag. After getting all the data, to calculate performance of the line by finding out the reactance and capacitance, we are going to find. Then after circuit constant, that are A, B, C, D constants, we are going to find. Then after receiving end voltage and sending end power, we are going to find. And circle diagram are useful for improving the voltage regulation, reducing the losses, and improvement of the power. So all this data we are going to calculate in the example, or whenever we are going to estimating our transmission line, that we are going to start one simple example, or we can say we can study this or with the help of simple example of designing the transmission line. So that's it for the today's module. I hope you understand all the concept that we are discussed in this video lecture. If you have any kind of query, then please ask me in the comment section. Thank you.